Hi, this is a demo that's an exploration into evals and tracing for AI systems. This is something I've been exploring this week, really important concepts in AI. I've been excited to take a closer look. Um, for background and context, when we build agentic applications, it's not enough just to generate answers. We need to know things like what happened, why did it happen, and importantly, whether or not the output is actually correct. And so to explore that, I'll show you a really simple demo app. This is a router agent with subagents, and we'll see how tracing and evals make the behavior of this demo actually observable. And so our demo app works like this. We have a router agent, which is going to take the user's query and then decide which subagent should handle it. And we have three subagents. We have a math agent, which evaluates arithmetic. We have a code agent, which generates Python code for programming tasks. And then we have a QA agent, just for answering general types of knowledge questions. This is intentionally really simple as a setup, but it mirrors a very common production pattern. A router directs traffic to the right specialized worker. What we're really focusing on today is how to trace and evaluate these runs. So here we can run the demo, jump in, and basically as this is running, the router is going to decide again whether to send the query to math, to code, or to QA. The chosen subagent is going to run and then return its result. And then we evaluate the run. So we use LLM as a judge, which is going to call another model and return either correct or incorrect with some rationale. And then we also have rule-based checks confirming things like the output length, math correctness, checking for whether or not code is present, that type of thing. So now that that's run, we can jump over and take a look at Phoenix. This is the Phoenix user interface. Phoenix is open source observability platform for LLMs and AI apps. So it basically helps us capture the traces, spans, and evals and gives us a single place to debug and monitor our AI systems. So Phoenix is a pretty good option because it captures the full journey of request automatically. It lets us attach evals to outputs. It provides a really nice UI for debugging and comparing runs, and it works both locally. I have it set up here locally, and also works in production. So here in the UI, we look at our traces. Each trace is one complete run of the app. And so you can see traces are, we've done 3 different demo queries. And then inside a trace, spans represent each step. So routing, subagent execution, and evals. And so we can see not just the answer, we can also see the evaluation verdict, whether it was correct or incorrect. We can see the inputs and outputs each step of the way. We can see the start time, latency, all that good stuff. So this combination of tracing and evals is really powerful. It turns our AI system from being more of a black box into something that now is very observable, it's very measurable, and we can make it more and more reliable. So in practice, evals, it's much more of an art than a science. Teams often combine different types of evals. So one, again, as I mentioned, LLM as a judge is quite common. It's very flexible for correctness checks. We can have things like rule-based checks for safety, for structure. We can do reference-based evals against our ground truth data. And then we can also have human feedback for calibration. So Phoenix makes it all easy to bring all these things together and monitor them over time. And again, as you're developing AI systems, but also as they're running in production. So while this router app, again, is very simple, it illustrates something much bigger. Every agent run becomes a trace we can analyze. Every output, every step of the way gets evaluated for quality. Each of those subagents, we're evaluating each of their responses for quality. And with Phoenix, we can monitor this continuously in production. And that's really the foundation for building AI systems that are trustworthy and observable. Thanks for listening. Hope you found this helpful.